All right, a bear spies some honey and takes off from rest, accelerating at a rate of 2 meters per second squared. So we've got 2, 4, 6, 8, 10. Okay. If the honey is 16 meters away, with what velocity will the bear's snout be moving at the moment of ecstasy when the bear's snout at full speed smashes into the honey? So we can solve this in 2 different ways. We can do our d equals half at squared to get our t, and then solve for our v. So let's start with that one. And we can also do it graphically, which I'll show next. So we've got 16 meters equals half. Our acceleration is 2 meters per second squared times time squared. So we'll have this cancels. We end up with 16 meters equals t squared. So 4 equals, and with our labels in there, we would end up with seconds, because this would cancel with that. On the other side, we'd have seconds squared, and then as we square root it, we'd end up with seconds. So t. All right, and then we have 4 seconds. So now we need to figure out if our velocity equals a times t. So velocity is going to be 2 meters per second squared times, times 4 seconds. So v equals 8 meters per second. All right, if we want to figure this out graphically, for the first second, we would have 2 times 1, and we'd have half of it. So this would be 1. If we come here, this would be 4 times 2, and that would be half of that. So that'd be 4. So a total 4, so that means this part would be 3, since that part's 1. Then we're going to go up to here. We have 6 times 3, which is 18. Half of that would be 9, so 9 total, so that's 9, 8, 7, 6, 5, so we'd have 5 left here. And then we can kind of tell our trend is basically just going up by odd numbers. So then we just need to figure out getting to 16 meters. We've got 1, 8, 9 right now, so if we add a 7 to that, we'd end up at 16. So that would be 4 seconds. We'd have v equals half our velocity, 8 meters per second, times our time of 4 seconds, which is then going to give us our 16 meters. So you could solve it graphically as well. Okay, an object with an initial position or initial velocity of 24 meters per second accelerates at a negative 6 meters per second squared for 6 seconds. So let's find out how much of a change that's going to be. 6 times 6 is 36. So that's going to be a negative 36. So I'm going to go from 24 meters per second to a negative 12 meters per second. So we want to figure out the total change in position. So at 6 seconds, I'm going to be down here. So then, at what point am I going to be at 0? So we'd have, it would take 6 times 4 is 24, so this should be 4 seconds that I would be at the 0 point. And that's what I'm going to need to know in order to figure out my overall change in position. So this goes through the 0 line, so we're going to have a negative number down here for this area and a positive number here for this area. So we're going to go ahead and take, graphically, half times 24 meters per second times 4 seconds. And then we're going to subtract, add negative 12 meters per second. That's what I was thinking, subtract. And this is going to be half also, times 2 seconds. So we're going to have 12 times 4 is 48 plus, that'd be, this is going to cancel that. So we're going to have a negative 12. So we're going to have 36 meters. Now we can prove that with our equation too, because we have our acceleration, we have our starting velocity, so we can do our half d equals half at squared plus our initial velocity times t. So we can go half negative 6 meters per second squared times our 6 seconds plus our initial velocity of 24 meters per second times 6 seconds. Okay, equals d. If we calculate this out, so we got a negative 36 divided by 2 would be a negative 18 plus 24 times 6 is going to give us 144. That doesn't seem right. Found the error, need a square here. So we're going to end up with 0.5 times 6 negative times 6 squared equals negative 108 plus 24 times 6 equals 144. So we're going to end up with a positive 36 meters this way as well. So both of those check out. If they aren't checking out, then there's probably an error like I made. Okay, a car's initial speed is 30 meters per second. If the car slows uniformly to 10 meters per second in 5 seconds, 30 meters per second, and we're going to go down to 10 in 5 seconds. Determine the distance traveled, or determine the acceleration of the car. So we're going, our change in v over change in t. Our final is 10 meters per second minus 30 meters per second, our initial, divided by 5 seconds. So we're going to have a negative 20 divided by 5 is going to be negative 4 meters per second squared. Determine the distance it travels in the second to the 3rd second. So that means I want to know, oops, if I'm talking 2 to 3 seconds, what is my area going to be there? So that means I'm going to have to figure out my velocity after 2 seconds and after 3 seconds. So if I take my v equals at at 2 seconds, so we'll have, I'm going to have to take it off of 30 as well. So I'm going to go ahead and put my 30 meters per second minus my acceleration, which is negative 4. Oh, I guess I can just add it then, since that's going to be negative, times 2, which is going to be a negative 8. So that'll get me down to 22 meters per second. And then at 3 seconds, v equals at. Again, I'm going to subtract from 30 meters, or I'm going to have the 30 meters per second and add. So I've got a negative 4 meters per second squared times 3 seconds. And that'll be 12. So I'm going to end up with 18 meters per second. So I'm at, oh man, 12, 18. So I'm going to have to figure out that little triangle from the 12 and 18. So I'm going to have d equals half the 22 minus 18 meters per second. And that's only for 1 second. and then I need to add my 12, or my no, that should be 22 and 18. Then I need my 18 meters per second for the 1 second because it was already going that. So that'll be this section. So I should have half of 2 meters per second times 1. So that's going to be 1 plus 18 should give me 19. Sorry, 22 minus 18 is 4 divided by, or times half, which would be 2 plus 18 is going to give me 20. All right. For the last one, object 1 accelerates from rest at 8 meters per second squared for 5 seconds, and the object 2 accelerates at half the rate for twice the time. So we'll have, after 5 seconds, this one will be going 40 meters per second, and that's in 5 seconds. And this one will have gone half the rate, 20 meters per second, over 10 seconds. And we want to compare these two. So change in position for the first one, we're going to have half 40 meters per second times 5 seconds. And then for the other one, we're going to have half 20 meters per second times 10 seconds. So this is going to be half of 200, so that's 100. And this is going to be 40 times 5, which is 200 divided by 2 or multiplied by half. It gives me 100. So we end up with the exact same change in position.